The topic of this video is inverse matrices. So let's suppose A is an n by n matrix. So that means it's a square matrix. Okay, another n by n matrix B is said to be the inverse of A if A times B is equal to the identity matrix. Okay, now remember the identity matrix is the matrix that has ones along the main diagonal, right? Ones along this main diagonal and zeros everywhere else. For example, the 3 by 3 identity matrix would look like this. Okay, it has ones along the diagonal and zeros everywhere else. Okay, so if you multiply A times B and you get the identity matrix, then B is the inverse of A. And we also say that A is the inverse of B. So it turns out that if A times B is the identity, then B times A will also be the identity. So we say A and B are inverses of each other. Okay, and also note, if B is the inverse of A, then we usually just write A with a little -1 here. This does not mean A to the -1 power. It means A inverse. Okay, we write that instead of B. So in other words, A times A inverse gives you the identity. Okay, now an important thing to note is that not all matrices have inverses. Well, for example, a matrix has to be square, okay, in order to have an inverse. If a matrix is not a square matrix, if you have like a 3 by 2 matrix, then it's definitely not going to have an inverse. But even with square matrices, not all of them have inverses. Okay, so not all matrices, even square matrices, have inverses. And in particular, the square matrices where the determinant is 0, those won't have inverses. Okay, so we haven't really talked about the determinant yet. But anyways, let's decide whether these matrices are inverses of each other. So we have a matrix here and a matrix here. If we multiply them together, do we get the identity matrix? Okay, so let's multiply these together. Okay, notice we have a 2 by 2 times a 2 by 2. So our result will also be a 2 by 2. So let's multiply these. Remember, we have to multiply the first row here by the first column. Now 5 times 2 is 10. 2 times -9/2 is -9. Okay, so 5 times 2 is 10. We have 10 plus a -9, that's 1. Okay, now we multiply this row by the second column, the first row by the second column. 5 times -1 is -5, and 2 times 5 halves, right? 2 times 5 halves is 5. So we have a -5 plus a 5, we get 0. Okay, so it's looking pretty good so far, right? This might end up being the identity matrix. We'll have to check. Now 9, 4, we'll multiply that row by the column 2, -9 halves. Well, if we do that, we get 9 times 2 is 18. And then if we multiply 4 times a -9 halves, we get -36 halves, which is -18. So we have 18 plus a -18, that's 0. Okay, and finally we do 9 times -1, that's -9. And 4 times 5 halves, that would be 20 halves, or 10. So we have a -9 plus 10, we get 1. So yes, they are inverses of each other because this is the identity matrix. Okay, so we've determined that these two matrices are inverses of each other. Okay, now in part B, what about these? Are these matrices inverses? Well, this would take a lot more work, but we'll notice something real quickly here. If we take this first row by this first column here, multiply these together. 2 times 4 is 8. So we're going to have 8 plus 15 plus 0. So 8 plus 15 plus 0, that's 23. Well, already we can tell. I don't even need to do any more calculations. Already we can tell that this is not going to be the identity matrix. So they're not inverses of each other. Okay, now another question that you could ask is, if I give you a matrix, can you find the inverse? Okay, how do you find the inverse? First of all, does it have an inverse? And if so, how do you find it? Well, that will be the topic of the next video.